Hey everyone, and welcome to the lesson on factoring by grouping. And this is going to be something that helps us get to the most kind of complicated version of factoring. It itself, is kind of a means to an end. So we're going to introduce this idea and then kind of fully utilize it in the lessons to come. But having the introduction is always nice. So ideally, our warm-up kind of takes us through these first few portions. But I have a quadratic statement, and the goal was to turn that quadratic into basically standard form. So standard form meaning turn it into something that looks like ax squared plus bx plus c. And to do that, you can kind of see that I distributed the 5x to the first set of parentheses, distributed a -2, important to make sure that that's negative, to the second set of parentheses, and then was combining like terms. And we end up with this quadratic. And what we're finding is that currently, I don't know, how we could solve this. I can't factor anything out. There's nothing common in all three of those terms, right? So that's what we learned to do in a previous lesson, was to say, oh, okay, if my a value or my first term isn't a 1, or it's not just a plain x squared there, then potentially I can factor a common factor out. But in this case, I can't. So this is kind of as challenging as factoring quadratics is going to get. But so can we solve this quadratic using our current strategies? No, our a value does not equal 1, and it's not a common factor of the rest of this stuff. So I can't solve it with any of my current strategies, but that's obviously why we're about to learn a new one. So if I take a look at this and I have 5x times x plus 3 minus 2 times x plus 3. What I want to bring our attention to is the fact that in both of these terms, okay, I have two different terms. This is a term and that is a term. In both of those, I have this x plus 3 that's sitting there. And what that means is that that itself is basically a common factor of both of those. So similar to, how we might see something that looks like 5x squared minus 10x, and I say, oh, and actually let's even just do an easier one than that. Let's say minus 2x. If I'm looking at something like this and I can say, oh, x is common between those two, so I can pull an x out, okay, and get this. That's the same thing we're going to do on the left, except instead of just taking an x out, we're going to drag out the entirety of this x plus 3. And when I do that, what I'm going to be left with is each of those terms on the inside being divided by that x plus 3. So this, if I take an x plus 3 out of that term, all I'm left with is 5x. And for my second term, if I take an x plus 3 out of there, then I'm just going to be left with this minus 2, and that equals 0. This is another good case where if I took this entire thing, or if I tried to visualize this, and I distributed just that entire x plus 3 to both of those, then I would end up with 5x times x plus 3 minus 2 times x plus 3. Okay? And that was what we started with. So sometimes it's easier a little bit to agree with it when it's written in reverse. So what I've done, essentially, is taken that quadratic expression that I didn't know how to solve, that was at the top or that I started with, and now I have it in a factored form. So I have two things being multiplied together to equal 0. We know that the only way that that can happen is if x plus 3 equals 0, or if 5x minus 2 equals 0. And then I have my two little mini expressions, which I'm going to solve separately. So I get x equals -3 from that. And then this one, if I add 2, 5x equals 2, dividing by 5 on both sides, I get x equals 2/5. And I can just leave it as that fraction, and that's totally fine. So we're only practicing kind of like the middle portion of this. It's unrealistic that we would encounter it probably in just this type of form. But again, this is going to be a tool that we're going to use moving forward. So we're going to kind of keep practicing just some of the basics of it today. So looking at these expressions on the bottom, and I'm asking myself, okay, I'm going to do factor by grouping. So what is common between these two terms that I'm seeing here? Well, they both have this x minus 4. So if I were to drag x minus 4 off of both of those terms, or factor it out, then this first term is just going to become x, right? Because I've factored that out. And my second term here, if I have this and I take away my x minus 4, I'm just going to be left with a positive 3, and that equals 0. So that is, I've changed the formatting of it so that now I actually can solve this. This is just a straightforward factored quadratic, so I can probably even just fast forward and jump right to x equals 4 and x equals -3, right? We're very used to those, ideally, at this point in time. Looking at my next expression, looking for a common factor within each, I see, oh, okay, I've got this 2x plus 4 between both of these, so I'm going to factor out 2x plus 4. And what I'm going to be left with when I do that is 5x minus 15 equals 0. Then I'm just going to solve these mini expressions. So those two things multiplied together are going to equal 0 if 2x plus 4 equals 0, or if 5x minus 15 equals 0. So if I go through and I start solving these, 2x equals -4, I'm going to divide both sides by 2 to get x equals -2 on this side. Here, adding 15 to both sides. Then I'm going to divide by 5 on both sides, so I get x equals 3. Okay, so these are the solutions to this quadratic that was written up here. And had I simplified this, I wouldn't have been able to solve it in a different way. But because it's in this kind of convenient format, I'm a little bit better off. To, again, kind of push ourselves and make this somewhat trickier, we're now going to try to generate basically that common factor between the two. So we definitely need to have practiced that skill that we had learned Thursday, which is to say, if I examine these as two separate pieces, these first two and these second two, okay? Within the first two, or in that teal, what are the common factors between those two numbers? I can take out a 2 and an x between those first two. And when I take 2x out of those, I'm going to be left with x plus 3. Convince yourself by going back and distributing this, but we would end up getting 2x squared plus 6x, which is where we started. Okay, so that is the first term dealt with. The second term, everything that's common between 4x and 12, well, I can take a 4 out of both of those. Those are both divisible by 4. So if I take a 4 out, then I'm going to be left with x plus 3. After doing that step, we should be able to realize that we've basically arrived at what we were just practicing, where we have a common term between these two things that I can now factor out. If you take that last step and you don't get this common term, then there was probably something different that we should have factored out, or something more. So just kind of be mindful of that. But here I'm going to say, okay, now I'm going to factor x plus 3 out of both of these terms. So if I take x plus 3 out of the first, I'm left with 2x. And if I take x plus 3 out of the second, then I'm going to be left with this plus 4 equals 0. This is perfect because everything is factored. So I have two things being multiplied together to equal 0. I just set each equal to 0, and then I solve from there. So here I'm going to divide both sides by 2, and I end up with these answers. So those are my solutions to that initial statement that we had here. Taking a look at this, everything that's common between these two terms, then I'm going to say everything that's common between these two. So between 3x squared and 6x, I can take a 3 out, and they also both have an x to give. So I can take 3x out. And when I take 3x out of this first expression, I'll just have 1x left over. And then when I take 3x out of here, I'm going to have just this minus 2. Convince yourself that when I distribute, I get what was in the yellow. For the highlighted red portion, looking to factor out the greatest common factor from there, I can take a 2 out. And when I take a 2 out of those, so I take this term and divide by 2, I get x. Take this term, divide by 2, I'm going to get minus 2. And then I'm seeing, that I generated what was my goal. I have this common term now between these two that I can then factor out of both. So if I take x minus 2 out of this, I'm going to be left with 3x. And if I take x minus 2 out of here, I'll be left with that positive 2. Going to set each equal to 0 and solve. So this is just going to give me x equals 2. And on this side, I'm going to end up with a fraction, but that's totally fine. So I get x equals negative 2/3 here, and I would just leave it like that. I will probably complete some of these additional problems here, just to kind of give you something to go off of and to practice. And then your goal will be to do these your turns. Okay, there are 6 questions, and there's a limited amount just because I know that it is a little bit tricky. But if we have questions, bring them into class so that we can handle them in person. If you think it can be handled via email, then we can also do that. All right, folks, thanks.